Welcome to the beginning of my ambitious Gumball Advent Calendar project. This is the point where we've done the talking and hyping up, and now it's time to put in some work. If you haven't already seen the announcement video, the Gumball Advent Calendar is exactly what it suggests. A fun way of bringing back the one gift a day rule to Advent calendars. That instead of ripping all the doors open at once like a cheap YouTuber. Here's a reminder of the requirements for the Gumball Advent Calendar. It must fit on a regular sized desk or table. It must only dispense one gift per day. It must contain individual gifts that combine to make a larger model, and it must be ready for December the 1st. In addition, I've been challenged by SilentMode's lab to creatively dispense the gifts using just one human interaction. The first thing I did was break down a project into smaller pieces to determine where to start. With a vague idea of features I wanted to include, the project was divided into 4 distinct sections. Electronics, involving the maker part of my skill set where I also get to do some programming. Design, as in the overall appearance of the Gumball Advent Calendar, including the materials used. Mechanics, creating the functional parts that go inside the machine. And build, designing the individual LEGO models that form a larger creation. As for where to begin, it was a process of elimination. There's no point worrying about the build until the machine is complete, although there's nothing to stop us coming up with ideas. It also doesn't make sense to obsess over the final design yet because we don't know what we have to include. The electronic side is admittedly the scariest, so we could argue it's the first thing we should tackle. I eventually decided to focus on the most fundamental working feature, which is why I began with mechanics. As you can see from these early prototypes, the original idea was to load the gifts from the top of the machine, and gravity would help a big wheel individually dispense the gifts when it turns. This would be the most straightforward approach, and it would be nice if that were the end of this chapter. The only problem is, it's boring. Along with being the easiest and most predictable method of dispensing gifts, it's also the most restrictive when it comes to design. As I discovered while creating these prototypes, the wheel occupies a significant amount of space inside the machine, so there's not much else we can add. If we're going to compete with SilentMode's lab and create something special, we need a different approach. The shift was made to thinking about how dispensing gifts could be made more interesting. How about this? Instead of loading gifts from the top of the machine and relying on gravity, why not load them from the bottom? And how can this be done? This is where all those hours spent watching how it's made videos could finally prove useful. Having seen those factory machines moving items around and, like most people, wondering how they were created, my thoughts turned to using a conveyor belt, one that moves items vertically. Ideally, this conveyor belt would be completely vertical so that it doesn't take up more space than necessary. Even with my lack of mechanical knowledge, I knew it would be more reliable to have a sloped conveyor belt for transporting the gifts. You know what though? Conveyor belts are complicated. Naturally, I looked up examples of 3D printed conveyor belts, thinking about how to model them myself and how they could be adapted for vertical movement. It became apparent that conveyor belts involve a lot of moving parts, the belt itself, the wheels and gears, and other things I can't think of right now. For someone with limited knowledge and virtually no scientific acumen, there's way too much that could go wrong designing a conveyor belt from scratch. By the way, I insist on designing parts myself because using other people's STLs gives me the ick. I could have found myself stuck between an overly simplistic wheel and a complicated conveyor belt, but a revelation came after remembering a classic toy from childhood. Who remembers the game Screwball Scramble? Well, it turns out the game I was thinking of was Kongman, and I remember having this mini version as a kid. It's similar enough though, so it's appropriate. I happened to come across a video of someone playing Screwball Scramble, and then I learned of 2 additional boards that can be added to the original. Both additional boards have a corkscrew mechanism which uses rotation to move the ball in a single direction. As you can see on both boards, the principle works both horizontally and vertically, with the bonus of consuming less real estate than a wheel or conveyor belts. There's my answer, if I'm able to recreate it. Before we become too invested in the project, it's imperative that I put these concepts to the test. 3D printing is invaluable for designing new parts and also determining what those parts are. There's a learning curve to creating models regardless of which software you use, and you'll probably learn the hard way about tolerances and clearances. but without 3D printing, I'd be limited to other people's existing components at the dimensions they've decided on, and that's assuming I'm able to get hold of them. Bearing in mind the Gumball Advent Calendar has to be ready for December the 1st, it's necessary to prototype quickly. My newest 3D printer, the E01 Mini, is the tool for the job. I'm using these 8mm wooden balls to represent the gumballs. The first step was recreating the corkscrew design using the coil tool in Fusion combined with a cylinder. At this point I was more concerned about aesthetics. The only problem was that the ball didn't fit. It's obvious now that the space between each of these revolutions has to be at least as large as the ball. Inconveniently, there's no way of measuring this distance in Fusion, but we can mitigate it by dynamically calculating the height of the coil. Another discovery was that the ball has to touch the wall while being pushed by the corkscrew, or it will just roll down. You can see with this example of a ball lift that the balls are being held by these two vertical bars while being pushed upwards by the coil. There was concern about the amount of support material used to print the corkscrew. Thank goodness I was printing them at this size. You can imagine how much there would be at full scale. Fortunately, this was addressed by adding a 45-degree chamfer under the threads, which prevented the model from needing support material. Finally, and this was the trickiest part, I considered how the ball would leave the ball lift. I found it difficult to incorporate an exit, which added a few more prototypes than I would have liked. In total, it took 21 attempts to produce something that worked reliably at this scale. This included allowing the balls to easily enter the lift, hopefully without getting stuck. Time to pat myself on the back for taking that first step into the unknown. I started with a vague idea of how the Gumball Advent Calendar would look and function, but the push for a more creative experience has changed everything. Gone is the original idea of a boring and predictable wheel that takes up space, and we've turned things on their head by introducing a ball lift. But where do we go from here? There's a case for starting work on the electronics, and one additional benefit of the ball lift is potentially using a simpler DC motor, which means I don't have to worry about controlling a stepper motor. The other option is to explore the Gumball's journey from the ball lift to the exit and the interesting possibilities in between. Which direction would you go in at this stage? Do you have any suggestions for how the Gumballs could exit the machine? Let me know your thoughts in the comments. Also, consider supporting the Gumball Advent Calendar and my work in general by becoming a patron. Thanks for watching, and until next time, this is Silent Mode, maker, artist and LEGO enthusiast, encouraging you all to do your thing.